So here's another example on U substitution. This one is a little bit unusual, and you'll see in a little bit why I say that. So our job is to integrate x times the square root of x minus 2. Any thoughts on how we should get started? First of all, let's kind of get rid of some possible mistakes from our system. Like, and once and for all, let me just show you. Like, for example, you should never do, when you have an integral problem, you should never do like integral of the first times the integral of the second. We just don't have such a rule, right? Because you can distribute integral over a sum or over a difference, right? But you cannot distribute an integral over a product. This is why integration is so difficult. There is no simple product rule for integration like there is in differentiation. There's a product rule for differentiation, right? This is why we have all these different techniques of integration, which U substitution is one of them. Okay, so any thoughts how I should get started here? Yes, Sandra? To the 1/2 power? Okay, the problem is we cannot yet distribute because anytime we have like a power, that power comes first, right? So we'd somehow have to take the power and then distribute the x, and we can't even take the power. Like if it was second power, that would have been a great idea. Distribute the second power, FOIL it, and then multiply by x. In this case, we're kind of stuck with square root. We cannot distribute it. So any other thoughts? Think in terms of U substitution. How could I apply U substitution here? If I had to choose U to be something, what would you let U be? How about x minus 2? Now, I know some of you are saying, wait a minute, you didn't tell us choose U in such a way that its derivative is already in there. Like in this case, derivative of du would be dx, or 1 dx, and then you're stuck with that extra x in there, right? But this is an unusual question. This would be like the type of question where that rule is a little bit, it doesn't apply in a sense. It applies, but it doesn't apply exactly. So let's continue and see how far we can get with this U, okay? Let's see what happens. So take the derivative of both sides. So du equals 1 times dx. I come back to the original integral. Where I see that square root, what should I write instead of that right now? The square root of U, because we call what's under it to be U. Okay, what about x dx? Now, it's going to be hard to replace both of them at the same time in this question. That's what makes it unusual. But I can go in bits and pieces. For example, what is dx in terms of U? We just determined dx is du, so I can put that in there. But now I'm stuck with this extra x. That's a problem. What? Yes, good ideas. I heard one from Madeline and Adam. Exactly. Both of you have the same good idea. My question was, how can I replace x and write something in terms of u? And the answer is, you have this equation that relates x and u, right? So solve for x in that equation. Solve for x. What do you get? X is equal to, just add 2 to both sides, right? So x is equal to u plus 2. So instead of x, then I can put up here u plus 2. Now, some of you might say, well, this doesn't look that much simpler than what we started with. I'm going to just rewrite it over here. We have u plus 2 times the square root of u, which is u to the 1/2 du. This is what we have instead of the given problem. Any thoughts how we can proceed on this integral? Now, does it look any better than what we started with? Looks a little bit better, right? It's still complicated looking, but what is it that we can do here we couldn't do earlier? Distribute. Now we can, because there's no power on u plus 2, right? We can distribute the u to the 1/2 one at a time, multiply it out. So you will have, what is u to the 1/2 times u? U to the 3/2, exactly. Plus u to the 1/2 times 2, that's 2 u to the 1/2. Okay, how does it look right now? Does it look like it's something we can differentiate? Certainly, right? So now we can apply, again, it's easy to integrate a sum because you can go one at a time, right? So let's integrate the first one. Integral of u to the 3/2 will be u to the 5/2 over 5/2, or times 2/5. integral of the second one will be u to the, you will add 1 to the power, so, or 2 over 2, so you have u to the 3/2 divide by 3/2 or multiply by 2/3 plus c, as we always have when we are integrating and there are no limits. And let me remind everybody something. Suppose you had limits of integration, say from 1 to 3. Would you plug them in right now, or would you wait until you bring the x variable back in? We need to bring back the x variable, because if you had integral from 1 to 3, those limits would have been set for the x variable. You need to get back the x variable into the equation. But in this case, we don't have limits yet. We still have to bring the x variable back, right? We don't want to leave the answer in terms of u. So before I bring the x variable, though, I want to simplify this a little bit. I have u to the 5/2, u to the 3/2. Could I factor anything out of this? And there's also 2 and 4, so I can factor a 2, that's for sure. And u to which power? Usually we factor it to the smallest power, right? Like if you have u squared, you take out a u from there. So now you have u to the 3/2, u to the 5/2. Let's take out the smallest power, which is 3/2. So let's take out a 3/2 power. And let's see what we're left with. In the first one, okay, the 2 is gone also. There's going to be a 5 on the bottom. Okay, I should put here u to which power, if any? Basically, you want the sum of this plus that to be, whatever you put in this box, to be 5/2, right? So you could put 2 over 2 in there, right? Which is like 1. So there's nothing to put, there's no reason to put anything there. And what about the second one? Plus, the 2 has been taken out, so now I have a 2/3 there. And I've already taken the 3/2 out, right? U to the 3/2 has been taken outside, so there's nothing left in terms of u in the second term. Okay. Again, I'm going to bring in u in a minute, but could I simplify this even a little bit further? You could get common denominators if you wanted to, right? For example, this top and bottom multiply by 3, this top and bottom multiply by 5. So I can rewrite everything as 2 times u to the 3/2 on the top 3u plus 10 on the bottom divided by 15. Again, I can put the 15 in there, or I can pull the 15 outside. Either way you do it is fine. And now I'm going to bring in the u. U was x minus 2. Yes, because when you simplify this quantity, what is inside the parentheses, you have 3u plus 10 over 15, right? So, and these are all being multiplied, so I can put that 15 anywhere I want it under any one of those factors. So you could either leave it like right here under 3u plus 10, you could have a 15 right there, or you could just write it up front. Either one would work. This is kind of like saying if you have 2 times 3 over 15, could you write it like this, 2 over 15 times 3? Because think about it, this side is 6 over 15, this side is 6 over 15. We can certainly do that, right? Okay. So I was about to put in the u variable into this expression on the left, and u was x minus 2. To which power should it be raised? 3/2, because we're putting it into this equation, right? So u is x minus 2 to the 3/2. And inside the parentheses, I want 3 times u. Again, u is x minus 2 plus 10. It looks like there's one last thing that we could do here. And what do you think that is? Distribute what's inside the brackets and simplify, right, as one expression. If you simplify all of that, what do you get? 3x, then you have minus 6 plus 10, which is plus 4. So I could leave my final answer as, and I promise this is the final, we're not simplifying this any further, 2 over 15 times x minus 2 to the 3/2 times quantity 3x plus 4. say this was probably one of the trickiest ones you might have. Again, remember your homework, I believe questions 67 and 69 or something near the end. You have a few questions where you put everything back in, you put the x's back in, or rather the u's, but you're left with one expression. Like in this case, we're left with x. Then remember, you have a defined equation, go back to it. You can get x in terms of u. Occasionally, you have to do this with u sub questions, but just be aware this is another technique that you can use.